Hello, guys. My name is Trilok Kalani. So, in this particular group, where myself and Matthew, for the ITAI 1378 final project, we have been working on the PPE compliance checker. And so it looks like a job site photo. And what it does is it finds pretty much every worker and decides whether each one is wearing their required safety gear, hard hat, and high vest. Are some of the safety gears that it enforces. The problem it solves is that manual spot checks don't really scale, and one safety officer can't watch every single worker all day, right? So the violations get logged inconsistently, and that's both a safety gap and a OSHA liability. So the pipeline is four steps. An image goes into a fine-tuned YOLO 11 detector, which finds every person and every piece of gear in a single pass. A rule engine that assigns each, detected item to the worker it belongs to, and each person comes out labeled compliant or non-compliant. And we are going to look at the technical approach, which is, the one of the important design choice is that the rule uses positive evidence. A worker is only compliant if the model actually detects, a helmet or a vest on them. And I'll come back to why, that matters a lot. It's one of the most interesting thing that I have found in this particular project. So everything is in the public repository, the notebooks. We fine-tuned YOLO 11 small on Ultralytics construction PP dataset. It's about 1400 labeled images. Training runs on a free collab T4 in under an hour. So the whole project cost $0. So here's a system running, green box, label compliant. The model detected a helmet and a vest on this worker, so the rule passes them. Let's get back to the image number two, which is called image 10 here. Now you see, this is the one I want you to look at. And as you can see, there are I think three red boxes, right, which are non-compliant for missing helmet. These workers have vest but no hard hats, and the system catches every one of them. This is the whole inference path. Point it at any image or folder and it writes annotated copies out. And this exact image is what our earlier version got wrong. It passed all of these people as compliant. Fixing that is what the second half of this project was all about. On the held out test split, 141 images the model never saw during training or model selection. I get MAP at 50 of 0.842. On validation, it's 0.827. Um, Inference is about 41 milliseconds per image on T4. So it beats the under 1 second latency target by a wide margin. And then and it handles crown scenes, multiple workers, each one evaluated independently. Per class, the two compliance decision actually depends on are the strongest. Helmet at 0.934 and vest at 0.904. Our target was 0.85, so we came in just under it. The gap is almost entirely in boots and gloves, which have the loosest bounding boxes in the data set. This is the whole interference. Here's the part I think is most interesting. Our second version was supposed to be an improvement, high resolution plus oversampling the rare violation classes it came out. Here's the part I think is most interesting. Our second version was supposed to be an improvement from the first version, the higher resolution plus oversampling, the rare violation classes. It came out worse at 0.608 down to 0.569. So we went digging and found three things. First, we sampled the images that carry no helmet style labels. 12 out of 12 were not construction sites at all, gyms, offices, family photos. And the second, the labels contradicted each other. The confusion matrix shows the model predicting boots on region labeled no boots 50% of the time. So the same pixels are annotated both ways in different images. Third, a catch-all class called none was swallowing real detections, 13% of true west. So our oversampling had been multiplying bad data. That's why it backfired. And the fix was to train on the six classes that were actually coherent and the rule actually uses and make the rule depend on positively detecting gear instead of trusting those broken labels. That's the version you just saw working. Two honest limitations, we are at 0.842 against a 0.85 target. And because we dropped the unreliable violation classes, the system infers a violation from missing gear rather than, detecting the violation directly. That's the deliberate trade and it's documented in the repo. Next step is the video extension running the same model on live stream, tracking workers across frames and logging compliance events with timestamps. Uh, Repo and slides are linked below. Thanks for watching.